A new station in lunar orbit, a platform that circles the moon. It would serve as a home workshop for astronauts' workshop for robotic systems. Its primary purpose: create a permanent human presence in the lunar environment. A critical link between Earth and the unexplored lunar surface. Not a destination, but a gateway. A crucial piece of infrastructure enabling complex, sustained activities. In orbit, a stable base always accessible. Independent of harsh lunar day-night cycles, ready to support exploration and science. A multi-purpose hub, fuel depot for topping up spacecraft, sophisticated laboratory for deep space experiments, operations base and command center to manage rovers' landers' human excursions on the surface. This essay explains the fundamentals of building and operating such a station. It examines significant costs, engineering limits, and long-term effects on our relationship with the moon. The station changes logistics of space travel beyond Earth. Today, missions are direct, point-to-point, launch to landing. A lunar station adds an intermediate step, making things manageable. Breaks the trip into smaller, flexible segments. Ships specialized for tasks. One for Earth to orbit, another for orbit to surface descent. Specialization could make lunar access more routine, more affordable, and ultimately more sustainable, moving us to continuous presence. Not just technical, strategic progress. At present, human spaceflight activity is largely confined to low Earth orbit. We have maintained a continuous human presence there for over 2 decades aboard the International Space Station. This has provided a wealth of knowledge about living in microgravity, but it is a relatively sheltered environment. Missions beyond this orbit are infrequent and complex. Space Launch System, SLS, capable of sending heavy payloads toward the moon. Starship, capable of sending heavy payloads toward the moon. Our infrastructure in deep space is non-existent, essentially starting from a blank slate for permanent lunar facilities. Nations have ambitious plans for the moon. Private entities have ambitious plans for the moon. Governments are planning new crewed missions to the lunar surface for the first time in over 50 years. Private companies are developing robotic landers to deliver scientific instruments and commercial cargo. Timeline graphic: completed robotic lunar missions 2010-2025 and planned missions 2026-2030. There is a surge of renewed interest and investment, a busy, sometimes competitive landscape. Despite forward momentum, there is a significant gap in the architecture. No central point for coordination, no place for crews to assemble, no depot to store resources. A new station is designed specifically to fill that void. Without a permanent station, every lunar mission is a standalone effort, increasing risk and cost. Each lander must carry all the fuel for its journey from Earth orbit to the lunar surface and potentially back. That requirement limits the size of the payload it can deliver. Communication often relies on direct line of sight or on a network of small relay satellites. Neither solution may offer continuous coverage. A station in a carefully chosen orbit could solve many of these problems at once. It could provide a reliable communications relay. It could act as a staging point for landers. It could serve as a safe haven for crews during surface emergencies. This gap presents a clear opportunity. The first entity or coalition to establish a functional orbital platform will define the next phase of lunar exploration. They will set docking mechanisms. They will set communication protocols. They will set safety procedures others will likely adopt. Building the station is about establishing leadership in the cislunar domain. It's an opportunity to build a cooperative international platform for science and commercial growth. That effort will help shape the rules of the road for decades in this new frontier. Building and operating a station in lunar orbit presents immense challenges, and the first major constraint is mass. Every single kilogram must be launched from Earth's deep gravity well. Solar panels, food supplies launch cost becomes a dominant design factor. A mission to lunar orbit needs far more energy than a trip to the ISS. Engineers design components to be ultralight yet strong. Total station mass equals a specific number of launches, each launch costing hundreds of millions of dollars. A second critical constraint is the harsh radiation environment. Far from Earth's magnetic protection, a lunar station faces higher radiation. Galactic cosmic rays solar particle events diagram comparing radiation exposure levels in LEO, GEO, and lunar orbit. This radiation risks astronauts' health, and it degrades sensitive electronics over time. Consequently, crew modules need far more shielding than in low Earth orbit. That shielding adds mass and increases launch costs, creating a tough trade-off between crew safety and budget. Communication delays are another fundamental reality. One-way radio delay, 1.3 seconds Earth to Moon. Round-trip conversation lag, over 2.5 seconds. This changes the dynamic of mission control. Real-time joystick-style control of robotic arms or rovers becomes difficult. Astronauts must have more autonomy for immediate tasks and emergencies. All procedures must be designed with that communication delay in mind. Finally, the station must contend with complex orbital mechanics. Lunar orbits are perturbed by the gravity of both Earth and the Sun. Near rectilinear halo orbit, favored for the gateway, is dynamically useful but not free. It still requires regular engine burns for station keeping. Station keeping consumes precious fuel that must be budgeted and resupplied. Docking and refueling 240,000 miles from home demand a new level of precision and automation. The margin for error is incredibly small and rescue options are limited. Section 4. The Pull of the Moon. Incentives for nations and companies. The significant challenges of building a lunar station are matched by powerful incentives that draw in both governments and private corporations. For the scientific community, the station represents an unparalleled research platform. It allows for the long-term study of the Moon itself, using remote sensing instruments to map its surface its composition in high detail. It also serves as a pristine observatory for deep space astronomy heliophysics, monitoring space weather, monitoring the solar wind without the interference of Earth's atmosphere or magnetic field. Placing experiments on the station is far simpler than designing them to survive a harsh lunar landing, opening up new avenues for discovery. So, the ultimate question remains, as we take this next great step, what kind of future are we trying to build? What scenario should we explore next? Share your ideas below. You've been watching Ifverse, where imagination meets possibility. See you in our next reality.